Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers vectors. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 15. The diagram shows triangle OAB and points C and D. So O to A is 3A and O to B is 3B. C lies on AB such that AC is 2CB. D is such that B to D is 2A plus B. Show using vectors that OCD is a straight line. Okay. Quite a lot going on there. Firstly, is all the information in the text on the diagram? And I think it isn't, is it? So this is O to A is 3, that's there, look. O to B is 3B, so that's there. C lies on AB such that AC equals 2CB. C lies on AB such that AC is 2 lots of CB. Okay, so this line here is in the ratio, it cuts in the ratio of 2 to 1 then, isn't it? Okay, that is useful. It can be useful for finding O to C as a ratio, as a vector in a minute. And then what else have we got? We've got D is such that B to D is 2A plus B. That isn't on there yet. Let's put it on. B to D is 2A plus B. So we know that this vector here is vector 2A plus BD, 2A plus B. 2A plus B. So, show using vectors that OCD is a straight line. OCD. So what we need to do is show that this is a straight line, apparently. So let's mark it on. Okay. Now, so another word is saying that the points O, C and D are collinear, that they lie in a straight line. Okay. Now to show that 3 points are collinear, you just need to show that one is a multiple of a scalar multiple of the other. So in other words, O to D is some multiple of O to C. Or you could show that O to C is some multiple of C to D. Same thing. Okay, so that's what we need to do. So basically, we need to find O to D and we need to find O to C in terms of the vectors that we know. And then we need to compare them and show that one is a scalar multiple of the other. Okay? Right, so let's do that then. Let's see if we can find O to C and O to D. So we're going to need to find O to C at some point. Okay? We are going to need to find O to D at some point. And then we're going to need to be able to express those as a scalar multiple of the other. Now, if I want to go from O to C, I need to go along routes that I know about. So probably I'm going to go along here and then down there, aren't I, to C. Okay? So O to C is going to be O to A plus A to C. Okay? But what is A to C? A to C is a fraction of A to B. And what's A to B? Let's find that first. Let's find A to B first. Once we know A to B, we'll find A to C. And once we've got A to C, we can find O to C. So A to B, if I'm starting at A, I'm going to B, I'm going to go along there and along there then, aren't I? Okay, so that's minus 3A plus 3B. So A to B is minus 3A plus 3B. A to C is, well, we knew that this, we were given the ratio of these two. The A to C was 2 and C to B is 1. which basically means that A to C is 2/3 of the length of A to B. So A to C is going to be 2/3 of A to B. Let's just move that down to make a bit more space. So 2/3 of AB, that's 2/3 of minus 3A plus 3B. So if I divide each one of those coefficients by 3 and times it by 2, I'm going to get minus 2A plus 2B, aren't I? Okay, because 2/3 of 3 is 2, and 2/3 of -3 is 2. -2. So I get that. So A to C is minus 2A plus 2B. So now I can work out O to C. O to C then is going to be O to A, which is 3A, plus A to C, which is minus 2A plus 2B, which comes out to be A plus 2B. Okay, that's great. So now I've got O to C. All I need to do is now find O to D as well. Now O to D is going to be O to B. Okay, just notice that some of this has fallen off your page. Let me just move that a bit over so you can see it all. Lost a B. Let's put it back on there. Okay, so then O to D is going to be O to B plus B to D. Okay, it's this route along here and then up here then, isn't it? Okay, so that is equal to 3B plus 2A plus B. So that comes out to be 2A plus 4B, which is 2 lots of A plus 2B, which is 2 lots of my O to C here then, isn't it? It's 2 lots of O to C. Okay, and now I've shown that O to D is 2 lots of O to C. So O to D is a scalar multiple of O to C, so they must be collinear. Okay, so I can therefore say that therefore OCD is a straight line. Okay, so a bit convoluted, but basically all you got to do is show that one is a multiple of the other to show that 3 points is lie in a straight line, which I've done. Okay. Question 20. OABC is a square. The vector O to A is vector A, and the vector O to C is B. M is the midpoint of AB. L is a point on MC such that LC equals 2ML. Use the vectors to prove that the line L lies on the line OB. Ooh, that's quite confusing, isn't it? So what do we know? So we've got our 2 vectors O to A and O to C, which are clearly marked. So there's my vector A, and there's my vector B. So I want to use vectors to prove that the point L lies on the line OB. Okay, well, what is the vector O to B to start off with then? To prove that it lies on OB, we need to find out what OB is. So the vector O to B then, what's that? O to B, the vector O to B. Well, if I want to get from O to B, I need to go along B and then across A because it's a square. So I know that CB is going to be the same thing as OA. So I can say that O to B is the same thing as O to C plus C to B, and that is the same thing as O to C plus O to A because it's a square, which is simply B plus A, isn't it? Vector B plus vector A. Okay, so far so good. So we found this line running through the middle is, and we've called it vector A plus B. That's A plus B. Okay, and then let's have a look at the other one now, M to C. What is M to C? So we can see that m to c then is equal to m to b plus b to c. Now m to b is going to be half b, isn't it? Okay, because m is the midpoint, and b to c is going to be minus a. Okay, so I've got half b minus a is my vector from m to c. Now we're told here that L is a point on MC such that LC equals 2 lots of ML. So the distance between L and C is twice the distance from M to L. So for every 1 you've got here, you've got 2 on this side, haven't you? Okay? So then the distance from M to L then is going to be 1/3 of the distance from M to C then, isn't it? Does that make sense? So M to L is going to be 1/3 of M to C. Okay, we've already worked out what MC is. It's half B minus A, isn't it? So that's equal to 1/3 of a half B minus A. Okay, removing the brackets, that is 1/6 of B minus 1/3 of A. Okay, so that's my ML. Now, so what is O to L? So if I wanted to start at the origin and I wanted to get to L, going along things I know. Now I know O to A, it's just A. A to M is half of B, and I've just found M to L, but it's 1/6 of B minus 1/3 of A. So I can get to from O to L via that route around the edge. Okay, so that's what I'm going to do. I'm going to work out what OL is in terms of those vectors. So we're going along vector A from O to A. It's O to A plus A to M plus M to L, isn't it? Okay, so we know O to A is A. We know that A to M is half B. And we know M to L now is 1/6 of B minus 1/3 of A. Okay, so what's that? Just collecting like terms, I've got an A minus 1/3 of A, so that leaves me with 2/3 of A. 2/3 of A, and then I've got 1/6 of B and 1/2 of B, so 1/2 plus 1/6, what's that? 1/2 plus 1/6 is, well, 3/6 plus 1/6 is 4/6. 4/6 is the same thing as 2/3, so I've got 2/3 of B as well, haven't I? So I've got 2/3 of A plus 2/3 of B, and now you'll see that they've both got 2/3 in common here, so I can take out 2/3 as a common factor. So it's 2/3 of A plus B then, isn't it? But I recognise A plus B. I wrote it down earlier. That is just O to B, isn't it? O to B is, well, I wrote B plus A, but it's the same thing as A plus B. So that there has got to be the same thing as O to B. So O to L is actually 2/3 of O to B. Okay, so if it's 2/3 of O to B, then it must lie on the line OB then, isn't it? Okay, if it's a scalar of O to B, it must be on the line OB. So therefore, L must lie on OB. Job done. Question 21, 5 points are connected by vectors. We're told that F to G is 2 lots of E to H. And then we need to work out F to E in terms of A plus B. Right, well, where is F to E? So this is the one we want to find, except going that way, aren't we? Now, but before we find it, we need to know what this one is, because we don't know what it is right now, and that's the only route that we can get there. But we do know that E to H is, sorry, F to G, which is what we've got here then, is 2 lots of E to H, and E to H then is this one here. Okay, so, but we don't know that one either. So what we're going to have to do first is we're going to have to find e to h using ways that we know. And then once we know e to h, we can double it up to find f to g. And then once we've got that, then we can find f to e. Okay, that's the plan. So we want to find e to h first. So if I'm at e and I want to go to h via routes that I know, the only way to get there at the moment via routes that I know about are going that way and then that way, because I know e to d is 3a plus b, and I know that d to h is a plus 6b. So I'm going to go from e to h via d. So I'm going to say that's the same thing as e to d plus d to h. Okay, and we've seen from the diagram that e to d is 3a plus b, and I know that from the diagram that d to h is a plus 6b. Okay, so notice that we've got terms in a and terms in b. These we can just collect together. So I've got 3a plus a, that's 4a, and I've got b plus 6b, that is 7b. Okay, so e to h is 4a plus 7b. Okay, so that's good going. Now I know what e to h is, I can now work out what f to g is, because I know that that's going to be 2 lots of e to h, and I just found e to h. So that's the same thing as 2 lots of 4a plus 7b. Now these vectors, they just multiply out the same way as algebraic terms, so you would just times that times by that, and I'm going to get 8a plus 14b. Okay, so that's my f to g. So now I know f to g, and now I know f to g, I can go on to find f to e, which is the one I actually was asked to find. So now let's go on and find f to g. Okay, so I might just color code these so they're easy for you to see. So e to h was the blue one, and that's what we found it to be. And then the green one we saw was 2 lots of e to h, which was this one here. So we doubled that one up, and then that gave us our f to g. And now we're finding f to e. Oh no, I don't know why I wrote down f to g. So then I'm finding f to e. That's the one I actually want to find, and I'm going to do that. If I go from f to g, I can do that going via ways that I know. Now I know how to get from f to g. I'm going to go via f to g, and then when I'm at f to g, I'm going to go from g to e, which I'm given in the diagram. Okay, so f to e is the yellow one. That's the one I want to find, and I get there by going along the green one first, and then when I get to g, then I'm going to go down this one here, the purple one. Okay, so that's my purple one. That's my purple route there. So I go along the green one and down the purple one. All right, so then f to g I know is 8a plus 14b, because I found it a minute ago, and I'm given the question, well, I'm not actually given g to e, I'm given, can you see the arrow goes the other way? So it's actually minus that, so I'm going to be taking that one away. It's a negative version of that, so I'm going to be taking away 2a plus 15b. Okay, because I'm going against the flow, I'm going against the arrow. Okay, so then taking that away then, so 8a take away 2a, that's going to be 6a, and 14b take away 15b, that is minus b. Okay, so that's our answer. F to e is 6a minus b. That's our final answer. Okay, that was fun. I like that. That was the pink route there. So just going to finish off my color coding. Yeah, there we go. Question 22. A, B, C and A, C, D are triangles and K is a constant. We've got a diagram here, and I can see I've got 3 vectors written on it. Part A says, show that the vector C to D is equal to 6 lots of vector A plus 4.5 lots of vector B. Okay, well, C to D is this line here, isn't it? We need to go from there to there. Now, we don't have any vectors marked along that length, but we do have one here and one here. So we can get from C to D by going via A. So that's what we need to do. So the vector, so we can say that the vector C to D is equal to the vector c to a plus the vector a to d. Now we know that the vector c to a, well, it's kind of going against that arrow, isn't it? If you look at c to a to c is 3b because the arrow is going this way. We're going against the arrow, so it's going to be minus 3b. So that's equal to negative 3b plus vector a to d, which is 6a plus 7.5b. Okay? Once we've written it like that, we can just collect together like terms, very much like we do with algebra. So we've got one term in vector a, and we've got two terms in vector b. So that's going to give me 6a plus 7.5b subtract 3b is 4.5b as requested. Okay, so 6a plus 4.5b, we've shown it. 22b says BCD is a straight line. Work out the value of k. You must show your work in. Let's go have a look at the diagram again. So BCD is a straight line. Work out the value of k. Okay, well k is up here. Look, it's on this stretch here. Now we can, and we're told that BCD is a straight line. Now we've already found the vector c to d. Now we can find the vector b to c using the vector ka plus my 3b there. And because B, C, D are three collinear points, or they're in a straight line, then the vector C to D is going to be some multiple of the vector BC, isn't it? Okay, because they're both going in the same direction. So we're going to use the fact that vector C to D is some scalar multiple of the vector B to C. Okay, where m is some number. Okay, doesn't really matter what that is at the moment. That's what we're going to show. We're going to show that these two vectors are going to be a scalar multiple of each other, and then hopefully we can work out what k is by comparing it with BC. Okay, so let's do that then. So C to D we've already found. So let's find B to C first. So B to C we can find by going via A like we did last time. So B to A plus A to C. So B to A is that vector Ka, and A to C is that vector 3b. So we're going with the arrows in both directions. So it's just simply Ka plus 3b. Okay? Now, we know that vector CD is some multiple of vector BC because they're three collinear points. In other words, C to D, which we found earlier, 6a plus 4.5b, that's the vector we found for CD earlier, is equal to some scalar multiple of our new vector that we found, Ka plus 3b. Okay? Now we can compare like with like. So we've got 4.5b is equal to, well, we can multiply this out if we want to. That might be easier to see. Let's just multiply that bit out. Equals mk lots of a plus 3m lots of b. Okay, so then we can directly compare these then. So 4.5b is equal to 3mb. So comparing the b parts, 3m then must be 4.5b. So what does that make m? 3 times what is 4.5? That makes m 1.5 then, doesn't it? If I times 3 by 1.5, I'll get 4.5. Okay, so then m must be 3 over 2, 1.5. And if m is 3.5, then I can say that my 6 from 6a must be equal to m lots of k. Okay, so 6 is going to be 3/2 of k. So 6 is equal to 3 over 2 lots of k. So rearranging that for k, cross multiplying, times in by 2, dividing by 3, I'm going to get 12 divided by 3, I know, which is 4. K is equal to 4. Okay. That comes about by the fact that if two vectors are equal, then their A parts must be equal and their B parts must be equal. So that's what I did. I kind of separated them out and compared them. Okay, but we come up with the answer. K is 4. Question 23, and we're on to vectors. Is BCD a straight line? Show your work and to support your answer. Now, if you want to show that 3 points are collinear, which means they lie in a straight line, what you want to do is to find that the vector from one to the other, so let's say that is vector A, then what you want to show is that this one is going to be some multiple of the same vector. Okay, and if you can show that that is the case, then you can say that they're collinear. So what we need to do is to find this vector, and we need to find this vector, and we need to show that one is a multiple of the other. Okay, let's see if we can do that then. So vector B to C, what's that then? Well, we can get from B to C by going up here and down here. We've got to travel along routes that we know. We don't know anything about the direct route, but we know those two, so we can use it to work it out. So B to C is B to A plus A to C, and B to A is 5A minus 2B, and A to C, well, we're going against the arrow here, aren't we? So that's subtract, not plus. So minus 3A plus B. Okay? So then just collecting like terms then, I've got 5A minus 3A, which gives me 2A. And I've got negative 2B subtract B. So negative 2B take away another B is negative 3B. Just take care with minus signs and brackets. So that gives me 2A minus 3B for B to C. Okay, now let's see if we can find C to D. So C to D. We could also find B to D, that's another way of doing it. And again, they would have to be multiples of each other. So C to D is 3A plus, well, let's go from C up to A, and then from A down to D. Okay, so we're going, oh, I've still got my pink highlighter, this way and then this way. Okay, so 3A plus B plus 3A minus 9B. They're both positive, aren't they? So that's equal to 3A plus B plus, what was it? 3A minus 9B. 3A minus 9B. So collecting like terms, 3A and 3A makes 6A, and B and minus 9B makes minus 8B. Okay. Well, are they collinear? Well, I don't think so. Now, if they were, so they're not collinear, are they? So B, C, and D are not collinear. That's the posh way of saying they don't lie in a straight line. As I think I'm going to say that B to C is not equal a multiple of C to D. Okay? Or you could write that down in words if you want, but yeah, it's not a multiple. Cannot be expressed as a multiple of C to D. Okay, question 23 is a vectors problem. I'm told that AFE is a straight line, and A to F to E is in the ratio of 3 to 2. So for every 3 we've got here, we've got 2 down there. Okay, we are told that DE is parallel to CF. So DE is parallel to CF. and DE equals 2 lots of CF. DE is 2 lots of CF. Okay. Okay, I haven't added that onto the diagram yet, so I'm just going to highlight it for myself to know that, to remember that I haven't used it. Okay, so work out D to E in terms of A, B, and C. D to E is, this length here. Now, in order to go from D to E, now at first glance this is a little bit tricky because we normally have to work out things in terms of routes that we know about. And so if I want to go from D to E, well, I don't know what D to E going directly is. I don't know what this route is because the only thing I've got it is A, and there's no other route that I can take in order to get from D to E along things that I do know about. However, we were told in the question that D to E is a multiple of CF, and I can work out what C to F is using routes I've been given. If I start at C, I could go this way and then this way and then this way. I've got nothing on A to F, but I have been given this ratio here which I can use in order to work out that section. So that's what I'm going to do. I'm going to work out C to F first by going around that green route, and then I'm going to scale it up to find D to E. Okay, so first off, let's find C to F. C to F is going to be C to B plus B to A plus A to F plus B to A plus A to F. Now, C to B is easy. It's given us 3C. B to A is easy. It's, well, the arrow's going the wrong way, isn't it? So that's minus 2B. Minus 2B. And then A to F. Now, we know that E to F, this bit down here, is A. And that A to F and F to E in the ratio of 3 to 2. So if I take A and I divide it by 2 and I times it by 3, I shall get this vector here. So this vector here is going to be A divided by 2 and times by 3. It's going to be 3A over 2. Okay, and again I'm going to go against the arrow, so it's minus. So it's going to be minus 3A over 2. Minus 3A over 2, like that. So that's the vector CF. Now the vector DE, we're told, is 2 lots of CF. So DE is 2 lots of C to F, which is 2 lots of that expression I just found. So multiplying everything by 2, I'm going to get 6C minus 4B minus 3A. That's my vector D to E. Question 23. PQR is a straight line, and we're told that the ratio of P to Q to R is in the ratio of 3 to 1, which basically means this part of the line is 3 times bigger than this part of the line, isn't it? Okay, and we know that P to Q is the vector A. So what is the vector R to Q? Okay, so P to Q is the vector A. So this vector here is A. Okay, now R to Q, this vector, is going in the opposite direction to A, and it's a third as big as A. So it's going to be minus 1/3 of A. Question 23. In triangle JKL, M is the midpoint of JK. Jn to NL is in the ratio of 3 to 2. And we're told that the vector KL is 7A and the vector N to L is 4B. Okay? Work out the vector J to M in terms of A, B. Give your answer in its simplest form. So what we need to do is we need to find this vector here then, isn't it? Okay? We need to find that one. What do we know? We only know this direction here, and we know this direction here. So basically what we're going to have to do is to find j to k, and then halve it to find j to m. Okay, I think that's what we're going to have to do. Now we've got some information up here that isn't in the diagram. First off, we've got that m is the midpoint of jk. So that means that this distance is the same as this one then, isn't it? Okay, so let's just mark that on. And we're also told that jn to nl is in the ratio of 3 to 2. So jn to nl, so this is 3 to 2 along here. Okay, so if this is in the ratio of 3 to 2 and nl is 4b, then if I divide that by 2 and times it by 3, it should tell me that j to n, then this part down here, is going to be 4b divided by 2 times by 3. It's going to be 6b, isn't it? That's going to be 6b. I'm just going to write that down, that if I've got, if n to l is 4b, and I know that j to n is 3 halves of 4b, then I know that j to n is 6b. And that tells me also that j to l is going to be j to n plus n to l, which is going to be 6b plus 4b, which is 10b. Okay, so I know j to l is 10b. I already know k to l is 7a. So then I can find an expression for j to k, so this distance all the way along here, well, going the other way actually. So what is the vector jk then? Going along places that I know. I can't go direct because I don't know anything about that line yet, but I know the other route. So I know that I can get from j to k by going from j to l and then going from l to k. Okay, and I know that j to l is 10b because I just found it, and I know that l to k is going to be minus 7a. Okay, because I'm going against that arrow, aren't I? So it's negative. Okay, so j to k is 10b minus 7a. Now what we want to know is what jm is, and we know that jm is the midpoint of jk, so j to m is going to be half of the vector j to k then, isn't it? Okay, so that is going to be half of 10b minus 7a, which is going to be, just multiplying that out, I'm going to get 5b minus 7 over 2a, like, just going to write it like that, 7 over 2a, it's like 3.5a. So the vector I want, j to m, is 5b minus 7 over 2a. Question 25, two congruent parallelograms PQRV and VRST are joined. So congruent in this case just means that these two parallelograms are identical, all the lengths and things are the same. So x is the midpoint of VT. X is the midpoint of VT, yes it is. VW to WR is in the ratio of 1 to 2. VW to WR is in the ratio of 1 to 2. Okay, so that means W is 1/3 or 2/3 of the distance along that line then, doesn't it? Prove that QW and X lie on a straight line. So what we want to do is show that these 3 points here, QWX, are collinear. Okay, now it doesn't look like it here because W isn't quite on the line if I just rule it through like that, but remember it's not drawn accurately, so and we need to show that it is, so it must be. Okay, so let's kind of work it out. So in order to show that they're collinear, what we need to do is to show that the vector Q to W is a scalar multiple of the vector, either the vector Q to X or the vector W to X. It doesn't really matter. I might go Q to X. So if I can show that q to w is a scalar multiple of q to x, or the other way around, then that tells me that q, w, and x are all collinear. They're all in a straight line. Okay, and the reason for that is that vectors have direction and magnitude. So if I'm starting in the same place and I end up one multiple further along, then I'm going to be moving in the same direction. So it means that they are all collinear. Okay, so that's what I need to show in order to prove this is true. So let's do that then. So what we're going to need to do is to find expressions for the vector q to w. We're going to have to find expressions for the vector q to x, and I'm going to have to show that one is a scalar multiple of the other. Okay, that is the plan of action. So let's see if we can do that then. So what is the vector q to w then? Right, q to w, how can I get from q to w along lines that I know? Well, I guess because it's a parallelogram, then opposite sides of a parallelogram are parallel and they're equal in length. So the vector from Q to R is going to be the same as the vector from P to V, isn't it? That's also going to be vector B. And the vector from R to V is going to be the same as the vector from Q to P. That's going to be vector A, going all the way from R to V. Okay, so if I want to go from Q to W, I'm going to go from Q to R, and when I get to R, I'm going to go from R to W. Okay, now Q to R I know is vector B, and I know that R to W is 2/3 of vector R to V. Okay, it's 2/3 of the distance, because I was given that ratio that V to W was W to R was 1 to 2. Okay, so the distance from there to there is going to be 2/3 of the distance going all the way up. So that is going to be B plus 2/3 of vector A then. Okay, so I've got vector B plus 2/3 of vector A. That's Q to W. Now I found Q to W. Next thing is to find Q to X. So how can I get from Q to X? So from Q to X, that is going to be equal to, going along things that I know, I can go up there, that's A, that's B, and that's half of B, isn't it, from there to there. So I can kind of go that way. So Q to X, Q to P plus P to V plus V to X, which is half of V to T. Okay, so that is going to be Q to P I know is A, P to V is B, and V to T is B, so half V to T is going to be half B, isn't it? So adding that up then, so that's equal to A plus, what's that, B plus half B, that's 3B over 2 then, isn't it? Okay, so now I've got expressions for QW and QX. Is there a way of showing that one is a multiple of the other? Well, no, I've got like a B here in QW, and I've got 3/2 of B in here. So if I kind of force factorize out 3/2 out of this, so if I kind of have a pair of brackets like this, and I force factorize 3/2 out, then I'm going to have 3/2 of B there. So how many A's would I need to have here, so that when I multiply it by 3 over 2, I get just one A? I'm going to have the reciprocal of 3 over 2, and I'm going to get 2/3. So if I have 2/3 of A and I times it by 3/2, I'm just going to get A back again, aren't I then? So then A plus 3B over 2 is the same thing as 3/2 of 2/3 A plus B, but 2/3 A plus B, that was QW. So I've shown then that Q to X is 3/2 of Q to W. Okay, in other words, one is a scalar multiple of the other, and by doing so I've now shown that Q, W and X must be collinear. Therefore Q, X and W are collinear, which means they lie in a straight line. Okay, so I did it. So on to vectors. ABCD is a parallelogram. We know that ABE is a straight line, and AB to BE is in the ratio of 3 to 2. So AB to BE is in a ratio of 3 to 2. So B to E is going to have to be a fraction of A to B then, isn't it? So if I take A and I divide it by 3 and I times it by 2, then it means that B to E is going to be 2/3 of A. It also says that BC and ED intersect at F. I'm sure we're going to have to use something to do with that a bit later on. But first off, we just need to show that, or to work out the vector E to D. So here's E down here, and here's D up here. So with vectors, we need to go along routes that we know about. So from getting from E to D, I'm going to have to go this way along here and up there. Okay, that's the route I need to go. So let's work that out then. E to D is going to be E to A plus A to D, and we know that E to A is going to be minus 2/3 of A minus another A plus B. So how many A's is that then? I've got minus 2/3 and another minus 1, so that makes minus 5/3 altogether. So it's going to be B minus 5/3 of A. Okay, let's go on to the next part then. Deduce that E to F, so deduce E to F in terms of A and B. So where's E to F? Okay, now looking at this triangle here, we can see it is similar to this large triangle. So the ratio of the bigger triangle is 5 to 2, because this was 2/3, look, and then from here all the way along to here was 5/3. So the small triangle is in a ratio, or the small triangle to the big triangle is in a ratio of 2 to 5, which means that this side here is going to be 2/5 of B. So from B to F, that's going to be 2B over 5. So then E to F is going to be minus 2/3 of A plus 2B over 5. So E to F is going to be, we say what, 2B over 5 minus, what was it? 2/3 of A. Question 26. ABCDE is a pentagon. Show that BCDE is a parallelogram. Now it doesn't look like a parallelogram in the diagram, but it's not drawn accurately. Now what are the properties of parallelogram? Parallelogram is made up of two pairs of equal and parallel lines. In other words, this line here has got to be equal in length and parallel to this line here. And this line here, CD, has got to be equal in length and parallel to this one. So to show that this shape is a parallelogram, all we've got to do then is show that this vector here is going to be the same as this one, and whatever the vector is here has got to be the same as this one here. Okay, so if I can show that those two vectors, two pairs of vectors are equal, then I've shown that it's a parallelogram. Okay, so let's start with DE, because I've been given that one. I've been given DE. So DE should be identical to CB. So here's C and there's B. Now can I get from C to B along routes that I know about? I can go along here, and I can go along here, and I can go along here. Okay, now they're going against the arrows, but that doesn't matter. Let's find vector C to B. Right, C to B is C to E plus E to A plus A to B. That's the root. Now, using the vectors A and B that have been given, C to E is against that arrow, so it's going to be the opposite of that, isn't it? It's going to be minus. So it's going to be minus B minus 2A. I'm going against that arrow as well. So E to A is minus 2B. Minus 2B. And A to B, again against the arrow, so that's going to be minus A. Let's just deal with that bracket. Minus B, minus minus is plus, so that's plus 2A minus 2B minus A. So right, we can start collecting like terms together then. So what have I got? I've got positive 2A and a minus A, so that's going to give me A, and I've got a minus B and a minus 2B, which gives me minus 3B. So my vector C to B is the vector A minus 3B. But hold on a minute, that's the same as the vector D to E, isn't it? A minus 3B. So I can say that is the same as D to E. Okay, so that's the first part done. I've shown that the green lines are equal in length and parallel. Now I need to do the same thing with the yellow lines. So let's take the vector BE to start with, work out what that is. So B to E, well, that's just along B to A and then A to E, isn't it? Yeah. B to A and then A to E, which is, this is a little easy, this bit is a bit easier, isn't it? A plus 2B. A plus 2B, so that one's already done. And we need to compare that with the other yellow one, C to D. What's C to D? Now C to D, I can get along that purple line and then down the green one. So from C to E and then from E to D. C to E and then E to D. So C to E is B minus 2A. Oh, it's going against the arrow, isn't it? So it's minus that. Minus B minus 2A. So minus B minus 2A. And then again, I'm going against the arrow of that one. So it's minus A minus 3B. Minus A minus 3B. Okay, and then we're dealing with all those negative signs. Minus B is just minus B. Minus negative 2A, that's plus 2A. Minus A is minus A. And minus minus 3B is plus 3B. Okay, now again, collecting up like terms. I've got minus B and a positive 3A. And I've got a positive 2A and then a minus A. So that gives me an A plus 2B, which you'll notice is the same as that one. So again, I can say, well, that is the same thing as B to E. Okay, so just to summarize that, I can say that CB equals DE. So C to B is equal to D to E, and B to E is equal to C to D. Therefore, B, C, D, E is a parallelogram. Okay, cool. Question 27. In the diagram, the vector from D to E is A, D to H is B, and H to G is 8B. The ratio of EX to XH is 3 to 1, and the ratio of EF to FG is 1 to 3. Show that the vector D to X is a quarter of A plus 3/4 of B. Okay, what have we got here then? So D to E, is that marked already? Yes, it is. D to E is here, look. Is D to H already marked? Yes, it is. D to H is here. Is H to G already marked? Yes, it is. It's down here, look. EX to XH equals 3 to 1. Is that already marked? EX to XH, that's that one there, look. So that is in the ratio of 3 to 1. So that means 3 parts up here for every 1 part we've got down here. And then finally we've got EF to FG, and that is in the ratio of 1 to 3. So that is 1 part to 3 parts along there. Okay, right, I'm just going to get rid of that color because too much. Okay, and then let's have a look at what we can do here. So I want to find the D to X. Where's D? D is here, look. Where's X? X is up here. Okay, now I want to go from D to X. Now I have to go along routes that I know. Okay, so to get from D to X, I would need to go, well, I can go along this one. I know that one, don't I? That's just B. But then I'd have to go up this line here. Okay, but I don't know that one. But I do know it's part of this line. It's like a quarter of it. And I can get from H to E via a different route. So I think what I'm going to do first is I'm going to find H to E, okay, as a vector. What is the vector H to E? Okay, once I know H to E, then I can find H to X. And once I know H to X, I can find D to X. That's my plan. Okay, so I've got my plan. Let's execute plan. Right, H to E, if I want to go from H to E along vectors that I know about, I can go from H to D along that green line, and then I can go from D to E along that yellow line. Okay, so vector H to E, that is the same thing as H to D plus D to E. And that is equal to, well, it's minus B plus A, okay, which you could write as A minus B, probably a little bit neater. I'm going to just spin that around and write that as A minus B. Actually, because it's minus B that is the H to D part, and then A is the D to E part. Okay, but it's A minus D. Okay, now I can't draw bold, so I'm going to draw those with little kind of hats on like that. Right, so I've done that one. Let's do H to X next. H to X is a fraction of H to E, isn't it? Okay, now if H to X is 1 part to every 3 parts we've got on the other side, then H to X is a quarter of H to E, isn't it? Because 1 plus 3 is 4. Okay, so it's 1 part out of 4 parts of the distance from H to E. Okay, so Hx, I'm going to say, is 1/4 of H to E. Okay, now I just found H to E. It was A minus B. So H to X is 1/4 of A minus B. Okay, doing good, doing good. Right, then finally, D to X. D to X then is D to H, which we know, plus H to X, which we know. So D to H is B, and then H to X is 1/4 of A minus B. What's that then? So just removing the brackets, I'm going to get B plus 1/4 of A minus 1/4 of B which is equal to a quarter of A. B, take away a quarter of B, that leaves me with 3/4 of B, which spookily is what I was looking for. There it is down there. So a quarter of A plus 3/4 of B. Good, we're done. Okay, so that was my workings for part A. Part B says, is DXF a straight line? Show working to support your answer. DXF. Okay, so D to X and X to F. It could be. Okay, now this diagram is not to scale. Now, if DXF is a straight line, then DX and F are what we call collinear points, which means that the vector D to X must be some multiple of the vector X to F, or the other way around. Okay, so if DXF is a straight line, now I could show that D to X is a multiple of X to F, or I can go D to X and D to F. I think that might be the easier route. If I can show that vector D to F is a multiple of the vector D to X, then that would imply that all those 3 points lie in a straight line, because they're sharing a starting point, D. Okay, and then if they have the same, if one is a multiple of the other, then they're going in the same direction, and therefore they should skew all the same points. Okay, so that should be sufficient proof if I can show that D to F is a multiple of D to X. Okay, I did think about doing D to X and X to F first, but like that would be too much work, whereas D to F looks a little bit easier to find. Okay, what is the vector D to F then? Now, to find D to F, presumably we are going to go from D to E along the yellow route, and then from E to F down here. I don't know that yet, but I can probably find E to G using E to D, and then D to H, and then H to G. Okay, so I need to find E to G, so then I can find E to F, and therefore I can find D to F. That's the plan. Okay, sounds like a great plan to me. So we need to find E to G first. So vector E to G, that is going to be E to D plus D to H plus H to G, isn't it? Okay, which is going to be E to D is minus A, D to H is B, and H to G is 8B. Okay, so what's that all together? That is 9B minus A. Just going to spin it around just to use one less sign. Okay, so now I know E to G, I can find E to F. So E to F then is going to be a fraction of E to G. What fraction is it? Again, I've got these in the parts 1 to 3. So E to F is 1 part out of 4 parts. So it's going to be a quarter of E to G then, isn't it? Okay, which is going to be a quarter of 9B minus A then. Okay, and then now I know E to F, I should be able to find D to F. So then D to F, that is going to be D to E plus E to F. Have I got space to do this? I think so. D to E is A, and E to F is a quarter of 9B minus A. So then what's that equal to? That is equal to, I've got a whole A minus a quarter of A, so that is 3/4 of A. And I've got 9b divided by 4, so that's 9b over 4. And they're both going to be positive. So 3/4 of a plus 9/4 of b. Okay? Well, I can see already, if I factorize out 3 out of that, then I should be on to a winner. Okay, so if I then factorize 3 out, I'm going to get... I'm just going to move that up a little bit, because otherwise I'm going to run out of space. So if I factorize a 3 out of those two terms, I'm going to get 3 lots of 1/4 of a plus 3/4 of b. Now you might wonder why I just factored 3 out and not 3/4, because a 4 could come out as well. But I'm using the fact that 1/4 a plus 3/4 of b, if you remember, is my vector dx, isn't it? Okay, so I can then say then that d to f is 3 lots of the vector d to x, which is what I wanted to show then, wasn't it? If you remember right back at the beginning, I said that I wanted to show that df was equal to some multiple of d to x, which is what I've done. Okay, so therefore dxf is a straight line. Awesome job. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.